everybody, my name is Tatiana and welcome to my video series on OTF Studio thin film software, a modern, smart and powerful software for designing, characterization, reverse engineering and monitoring of multi-layer optical coatings. Precise knowledge of substrate optical properties is essential for the theoretical design and monitoring of optical coatings, as well as for layer characterization and reverse engineering of produced coatings. For broadband design and production, it's important to know accurate substrate data across the entire spectral range. In this video, I demonstrate a reliable method for estimating optical constants of substrates using OTF Studio software. A combination of measurement data set and characterization algorithm are important for reliable determination of substrate optical constants. Typically, spectral photometric data, reflectance and transmittance are used for substrate characterization. I open OTF Studio project for substrate characterization. I open the project in CH characterization mode. It's easy to switch between different modes using quick access toolbar. I have several measurements for several substrates in my disposal. And in this example, I will start with S-LAH66 substrate. I have measured reflectance, quasi-normal incidence, transmittance at 8 degrees, and in the range 220-1600 nanometer. I loaded the measurements. These two check boxes indicate that backside is included to the measurements. And substrate thickness is 2 millimeter. Typically, a preliminary estimation of systematic offsets in reflectance and transmittance measurement data can be achieved by analyzing the total optical losses within the substrate's transparency spectral range. And I can open in view ribbon optical losses and place, using docking, place this plot in convenient location. This is optical losses, and I can zoom in the transparency range from 500 to 1600 nanometer. Zoom in again. And we can see that the average level of optical losses is about 0.1%, which can be considered as offset level. Total optical losses can be estimated as 100% minus reflectance minus transmittance in percent, and ideally reflectance and transmittance are measured at the same incident angle and at the same spot of the sample. If high-quality super-polished substrates are used, it's possible to neglect scattering losses. The average level of total losses can serve as an estimate of the systematic offset in measurement data. The level of the offset of the considered measurement data was estimated as 0.1% in the wavelength range 500-1600 nanometer. It is clear that in so broadband spectral range from 220 to 1600 nanometer, it's not possible to describe dispersion behavior of refractive index and extinction coefficient using a simple model like Cauchy, Zellmeyer, or exponential model. OTF Studio has, for such cases, semi-analytical method. I focus on the substrate model builder and select arbitrary function for n and arbitrary function for k. And without any additional fitting, additional algorithm, we obtain excellent fitting, and we obtain characterization result. This is refractive index, extinction coefficient, and using docking, I can place these plots in two different places. And this is a solution of our problem. But what is the process behind making this method so effective? The numerical characterization was performed using a semi-analytical method based on explicit formulas, allowing to determine a refractive index and extinction coefficient at all wavelength points at the measurement wavelength grid. Namely, this nonlinear system can be resolved at each wavelength point independently using transmittance and reflectance values measured at quasi-normal incidence. ds is substrate thickness. If you are interested in learning more about this method, feel free to check out the references listed in the description of this video. In some cases, refractive index value at specific standard wavelengths are provided by the manufacturer. These reference points can be used to verify the results. We can see if we compare our result, this red curve, with verification points, we can see the excellent correspondence between characterization results and verification points. And this is indication of reliability of obtained results. In the same way, I can characterize a zinc selenide substrate. I have measurement data from 400 to 4200 nanometer, reflectance and transmittance at 8 degrees. I focus on the model builder and select arbitrary n and arbitrary k functions and immediately get the result. If I would like to compare this result with literature data, I can focus on view, compare, select substrates, and select zinc selenide substrate from refractive index info, and we can see excellent correspondence between current result and this reference. Thank you for watching. If you have questions, please contact me, and see you in the next video. Bye!